Okay, my goal in this video is to walk you through the 5 questions that are on your practice assignment, because I feel that these 5 questions will also be appearing on your real assignment, just with different substances, but essentially follow the same characteristics. So I think that if you can do this practice assignment, that you are ready to go. Okay, so the first question is calculate the molar concentration of a 58.5 grams of aluminum sulfate in 855 milliliters of solution. Okay, so one thing I'll tell you right off the bat is that, the fact that it's 4 marks as opposed to maybe 7 or 8 marks, this isn't going to be a stoichiometry question. There's only one substance here. It's not like it's 2 substances. You're not going to need to write a reaction. So I'm just trying to encourage you to look for those things. So I'm going to show you using my GRASS techniques is that I look at this and I say, okay, well, I've been given 58.5 grams. So I know that that's a little m. That's a sample mass is 58.5 grams. It's aluminum sulfate. So I'm going to come over here and write out the chemical formula. So it's Al, and Al is +3. And then sulfate is SO4, and it's -2. So I do need to crisscross those charges. So it's Al2, SO4, 3. And then finally, I've been given the volume. So the volume is equal to 855 milliliters. And I know that if it's molar concentration, then I'm going to need it in liters. So I'm going to divide by 1,000. And I get 0.855 liters. So I'm kind of preparing myself. Okay, now it says that the required is the molar concentration, which I know is C. So C is molar concentration. And the formula that I've got that I learned in this unit is that C is equal to N over V. Okay, so I feel this is kind of the nice setup for it. Now the problem is that obviously I don't have the N, but the fact that I've been given the little m, and I know that I've got other methods of converting, and so I can say, well, my number of moles is going to be the sample mass divided by the molar mass. So there you go. I've got 2 different formulas. I'm going to have to solve this one and then sub it into this equation to get my molar concentration. And the one other thing I'm going to need is I'm going to need to go to my periodic table and calculate the molar mass of Al2 SO4 3. And so I would go and I would calculate 2 times the mass of aluminum, 3 times the mass of sulfur, and then 12 times the mass of oxygen. And I've already done that, and it's 342.17 grams per mole. Okay, you may be a little bit off that, but that's essentially what this is. Okay, so here we go. Let's sub and solve into this. So the number of moles is going to be 58.5 grams divided by 342.17 grams per mole. And when you divide that, you get 0.171 moles. Okay, and then we come on over here and we take that 0.171 moles and we divide. We've already converted to liters, so divide by 0.855 liters. And when we divide that, we get 0.200 moles per liter. So there's our concentration. Okay, so that's the really typical kind of a question that is just asking for molar concentration. Remember, that was one of our 5 excuse me, one of our 5 methods of calculating concentration. It was the one that's most often used, and so this is a nice question to kind of show that you can do those 2 steps. Okay, the second question, and this was again, it's not a big marker, it's only 3 marks, so it's probably not, it's not going to be a reaction where you have to do the 4 steps of stoichiometry. But look what it tells us. It says what volume of this concentration of sulfuric acid is needed to make 100 milliliters of this concentration. Oh, so I'm hoping what you guys will see here is that this is a dilution question. So it's the same substance, sulfuric acid, and they're just diluting it. They're going from a concentrated value down to a dilute value. Okay, so here we go. And again, it's just a question of setting it up, given required analysis. Now, one thing I'm going to say is that I recognized right off the bat that it was a C1 V1 is equal to C2 V2 question. That's this dilution formula. Okay, so it says what volume, so the one thing they're asking you to calculate a volume of this. Now, I noticed right off the bat, there are my 2 concentrations. I told you in the study notes video that these 2 are always associated, well, they don't have to be, but by convention, we make these 2 the concentrated values, and we make these 2 the dilute values. Okay, so look at this then. As I read the question, it says, what volume of this one? So this one is a concentration, so I'm going to write, I know it's a concentration because of its units, are moles per liter. So I go 3.5 moles per liter. It says, now I look at the other concentration and it's a smaller number. So look at this, I'm going to call this one C1 because it's the more concentrated one. All right, and it says what volume of it, so this must be the V1. The other 2, it says, is needed to make 100 milliliters. And so look at this. I'm going to call that V2, which is my dilute volume. And then my C2 is the 0.45 moles per liter. So that's the hardest part of this question, is making sure that you define your variables correctly. Okay. I'm going to get rid of these now, so I don't want people to be confused. So those 2 are our concentrated, these 2 are our dilute. Okay, so look at this. Now I'm ready to sub and solve. Now some of you may say, well, Mr. Webster, shouldn't you be converting that 100 milliliters there into liters? And in the dilution formula, you don't have to. You can leave it as milliliters, and it just means that your answer is in milliliters. Now, for some of you that want to convert it, do it. There's no problem at all. All right, so here we go. We're going to sub and solve. And so we're going to go 3.5. I'm substituting my C1, and then my V1 is unknown, so I'm going to leave it as a V1, is equal to 0.45, that's my C2, times 100 milliliters. And then to solve this, I divide the 3.5 off this side because I want V1 by itself. Whatever I do to one side of math, I do to the other. And so I'm going to go 0.45 times 100 divided by 3.5. And when you do that, you get 13 milliliters. Okay? Essentially, and you know, as long as, remember, because this was in milliliters, my answer is in milliliters. If I had put 0.1 liters in there, my answer would have been in liters. Okay? All right, so there's that one. That's another, you know, kind of typical question. Okay, let's go to the next one. The next one says, okay, so this one is where it wants you to write, we want to write the total ionic equation and the net ionic equation. And I always start off with the molecular equation. Okay, so let's do, this is that lesson where we kind of did all 3 of these equations. So let me walk you through it. So it says a solution of sodium sulfide. So I'm going to come up here and I'm going to start by writing Na, and then Na I know is +1, and S is -2, so I'm going to crisscross down here. Now it tells me it's a solution, so look at this. I'm going to write aqueous there. Is mixed with a solution of copper 2 chloride. So here I go. I'm going to go well, plus, and then it's Cu, and it's the 2 tells me the charge, so it's +2. Chlorine is Cl, and it's -1. So again, I've got a crisscross. So it's CuCl2 aqueous. Okay, they're mixed. Arrow. So at this point, that's all I know. Now, what I'm filling in here is the molecular equation. This is the equation from Unit 2. And so in order to figure out whether or not a reaction occurs, I need to go to my solubility guidelines. So I'm going to pull out my solubility guidelines. Give me a second. Here they are. So I've got my solubility guidelines, and I flip them over. I find what I'm going to do is I'm going to compare Na to Cl to see if they form a solid, and I'm going to compare Cu and S to see if they form a solid. Now, I got to be honest, I've done this enough to know that NaNCl, which is table salt, is very soluble, so it does not form a solid. But let me check Cu and S, and sure enough, I see that it is in the bottom row and it forms a solid. So then what I'm going to do is I'm going to come over here and I'm going to write Cu, and I know that it's a +2 ion. I already checked that. And then S -2. Oh, so I don't need to crisscross my charges. I know that that's copper 2 sulfide is going to make a solid. Cool. And then the other two you just put together. You would just go plus NaCl, and they remain aqueous. Before I leave my molecular equation, I'm going to balance it. And so I look here and I see that there's 2 NAs and 2 CLs. Oh, good. So I just need a 2 there, and I'm balanced. That, you guys, is an important first step to do in this question. You write down your 2 aqueous solutions, you compare the anions, and you figure out which one of them is going to form the solid, and then write it out and balance it. You're now prepared for the main part, which is to then change this into a total ionic equation. In a total ionic equation, anything that's aqueous, you're going to break apart into its ions. The solids you will leave together. So watch this. I am going to break this apart. So I'd come down here and I'd write, okay, well, I know that the ion is sodium +1. All right, but there are 2 of them there, so that's why I moved the 2 out front. So 2 sodium +1s plus, all right, it's just S -2, and this is aqueous, and this is aqueous, plus here it's just copper +2 aqueous plus 2 chloride aqueous. So there you go. I've broken it apart. One thing to remember is that if there had have been a number out front here, you would have to include that with each of these. So I'm just going to give you an example. If there had been a 2 out front, it would have been 2 Cu2 plus, and then 4, because it would be 2 times 2, would be 4 Cl minuses. Now obviously that wasn't there, so I'm going to get rid of it. There you go. You've written out your reactants in their total ionic form. Now, for the products, you keep the CuS together because it's a solid, but then I'm going to break apart these ones. So I get 2 Na plus aqueous plus 2 Cl minus aqueous. And if you've done it correctly, this should be balanced. So sure enough, look at this. I've got 2 NAs on this side, 2 NAs over here. 2 Cl minuses, 2 Cl minuses, 1 S, 1 S, 1 Cu, 1 Cu. So that's what we call the total ionic equation. And then the net ionic equation, you get rid of your spectator ions. So one thing I'm going to do right off the bat is I'm going to circle Na plus, I'm going to circle Cl minus. The spectator ions don't change, and so those ones are all spectator ions. They're what we call spectator ions. And so I am going to get rid of them as I write my last equation, which is my total, my net ionic. So I'm going to go S minus 2 aqueous plus Cu plus 2 aqueous makes CuS solid. That's what we call the total ionic equation. So there you go. That's a really good example of, that's 5 marks for writing out your balanced equation, your total ionic, your net ionic, and then identifying your spectator ions. Okay? A couple more questions here. So this one is 8 marks, and so you can clearly see that this one's going to involve some steps. And what I'll tell you is that this one it's one of our stoichiometry questions. And so it's, you know, and it shows here is reacted with, so you know you're going to have to be writing a reaction out. And you've been given 2 different substances, and then what's the mass of the precipitate. So there's quite a bit to be done here. And so I'm hoping that you recognize this one as one of our stoichiometry with solutions. And we did a bunch of these as examples for homework. So step number 1 of stoichiometry is to write the reaction. All right, so here we go. Copper 1 sulfate. So I'm going to come down here and I'm going to go, okay, well that's Cu plus 1, and then sulfate is SO4 minus 2. I'm going to crisscross those, so it's Cu2SO4. I'm told that it's a solution, so it's aqueous. And look at this. I'm going to write right underneath it, it says I've got a volume of 1 liter, and I've got a concentration of 0.1 moles per liter. Okay, so copper 1 sulfate plus sodium bromide, so Na. Man, I don't know why it's doing that. Sodium plus 1, bromide is Br minus 1, and it's aqueous. I know it's a solution. I don't need to crisscross because those are the same charge. But look, I'm told that I've got a volume there of 250 milliliters, and here I've got a concentration of 0.6 moles per liter. Okay, so they're combined, and so they react. Now it's already told me that a precipitate forms, so I'm pretty sure that there's going to be a precipitate, but let me go to my solubility guidelines. I've got to compare Na and SO4, and I've got to compare Br and Cu. So I quickly go and I grab my solubility guidelines, I go to SO4, and most things are soluble with it, and Na is not insoluble, so I'm going to put an X there, means that doesn't form a solid. But look at this, if I go to bromide and then Cu plus 1, yes, there it is. That's my solid, so I'm going to come on over here and I'm going to go Cu Br, and this is plus 1 and minus 1, and it forms a solid. I don't need to crisscross. But then what I'll do is I'll just put the other 2 together. So I'll put Na, and then SO4. This one's a plus 1, this one's a minus 2, so I do need to crisscross, but they remain aqueous. So look at this, it says this reaction forms a brown precipitate, so it clearly is the copper bromide. And what is the mass? So the question being asked in this question is what mass of that is formed? Cool. We're almost done step number 1. We need to make sure we balance the equation. And so I take a look at this and I see that I need, I'm going to need a 2 in front here to make sure that I have 2 coppers on both sides, and then a 2 in front there, because now I'll have 2 NAs on both sides, 2 BRs on both sides. I'm good. Okay, so don't forget to do your little balancing of the equation. So at that point, I'm done step number 1 of stoichiometry. Okay, step number 2 of stoichiometry says convert everything to moles. And so if you've got a concentration and a volume, you do N is equal to CV. So this one's pretty easy because it's already in liters, so it's going to be 0.1 times 1 liter. So I have 0.1 moles. Okay, over here, I've got to convert this to liters. So I'm going to go, oh, that's 0.25 liters. I divided it by 1,000. And then I said, well, N is equal to CV. So it's 0.6 times 0.25. Here we go, 0.6 times 0.25. And I get 0.15 moles per liter. Oh, sorry, moles, my apologies. 0.15 moles. Okay. So which one of them is limiting? Well, remember, you've got to do one little additional step, which is you've got to divide them by their coefficient. And so it's 0.1 divided by 1, which is 0.1, so it doesn't change. But look at this one. It goes from 0.15 divided by 2, and you get 0.075. So this one, when you is smaller than this one, so this one is limiting. But remember, for my mole ratio, I'm going to go back here. So first of all, I put an X through that just to remind me that it's excess. And I'm actually going to put an X through this one because I only used that to determine which one was limiting. And that leaves me with this 0.15 that is going to be what I'm going to carry to the next step. Okay, so we've done the limit, we've done step number 2, we converted to moles, we figured out which one was limiting. Now we're going to do a mole ratio. That's step number 3 of stoichiometry. And we're always interested in 2 things. In this case, we're interested in the limiting reactant, and then we're interested in the one that we're trying to solve something about. So I'm going to write NaBr2 CuBr, and this is a nice one because it's a 1-to-1. It's CuBr, and I noticed that the ratio was 2 to 2, which is essentially a 1-to-1. You always have one ratio from your balanced equation, and then it's 0.15 to x. That's where I bring the 0.15 down. But if I know this is 2 to 2, or it's an equal rate, then I know that this is also 0.15. That's the same. So it means that whatever moles I have of the sodium bromide, I would also have of the copper bromide. So there we go. We're almost done. We're going to go back up here, and we're going to go to step number 4 of stoichiometry. Mass is equal to little n times big M. We calculated that it was 0.15 moles. And now I just need to go to calculate the molar mass of copper bromide. And so give me 1 second here. I am going to say, let's see here, copper bromide is, I'll get my periodic table out. Here, I'll just go down to the bottom. And so the molar mass of copper bromide is, copper is 63.55, and there's one of them. Bromine is 79.90, so I add those, 63.55 plus 79.90. I get 143.45. 143.45, and then times 0.15, so I get 21.5 grams of the copper bromide. Okay, so that is an 8-mark question. It's involves the steps of stoichiometry. We got to do limiting reactants. We had to predict products, and then we had to calculate our whatever, in this case, the mass that was created. Okay, so that's a pretty good example. The last question is, again, it's very similar. What you'll see here is that it's also a stoichiometry question, but this one's an acid and a base reaction. So let's try this one out. It says 8.54 milliliters of a 0.5 mole per liter phosphoric acid is needed to neutralize. Remember, neutralize is the same thing as a reaction. 30 milliliters of barium hydroxide. What is the concentration of barium hydroxide solution? So the one thing I want to, a lot of students sometimes will think that this is a C1 V1 is equal to C2 V2 question. It's a dilution question. It's not, because look at this, we're dealing with two different substances. And so it's an acid-base reaction. So look at this. We know that an acid plus a base react to make a salt plus water. All right, so here we go. The acid is phosphoric acid, which is H3PO4 aqueous, is combined with a base, which was barium hydroxide. So it's barium hydroxide, and it's +2 and -1. So it's got to be BaOH2, barium hydroxide. And now, I know that one thing that's made is water. That's the easy one. But look at this. It's always the cation from the base and the anion from the acid. So what I'm going to make is BaPO4. This is +2. This is -3. So I got to crisscross those. And there you go. So that's what I'm making. And now what I'm going to do is I'm going to balance it. And so I look here, well, I have 3 BAs on that side, so I'm going to put a 3 out front there. I have 2 PO4s, so I'm going to put a 2 there. And then for the height, or the H2Os, I'll need a 6. Okay, so that, you guys, I'll just write that I've got a volume here of 8.54 milliliters. I've got a concentration here of 0.5 moles per liter, and I've got a volume here of 30 milliliters. And what they're asking for is what is the concentration of the barium? So the question mark is, what concentrated is needed to neutralize it? Okay, so at this point, we are done step number 1 of stoichiometry. We've written a balanced equation of our acid and base neutralization, and we've written down what we've been given. Okay, so step number 2 of stoichiometry is to convert to moles. Well, the only one that I've got enough to convert to moles is this first one. So look at this. N is equal to C times V. Now, I need to get to liters, so look at this, divide this by 1,000, and it's 0.00854 liters. So here we go, 0.00854 is my liters, times, so 0.5 is my concentration, 0.00854 is my volume. So times 0.5 equals, I get 0.00427 moles. Okay. Now here's the thing. What I want to do next in stoichiometry is I want to do a mole ratio. Well, what I'm interested in is the barium hydroxide. I'm trying to solve for the concentration. And really, I know that they'll be neutralized when they are stoichiometrically equal. So this is the one that I want the mole ratio for. So watch this. I've got something about the phosphoric acid. So H3PO4 is one of my solutions. The other one is barium hydroxide. And so look at this. I always get one of my ratios from my balanced equation. So it's a 2 to 3 ratio. And look at this. I know that I've got 0.00427 moles of the phosphoric acid. How many moles of the barium hydroxide do I need? So there's my mole ratio. Let's cross multiply this. So I'm going to multiply the x up, and so it becomes 2x is equal to 3 times 0.00427. And then I'm going to divide by 2. And so the number of moles of barium hydroxide is 0.006405. That's how many moles I would need to neutralize that acid. And so finally, step number 4 of stoichiometry is to convert back. They want C. Well, C is equal to N over V. I know that's the number of moles I need, 0.006405. That's the moles. The volume I have is 30 milliliters, so that's 0.03 liters. You divide it by 1,000, so divided by 0.03 liters, divided by 0.03, and I get 0.2135 moles per liter. Okay, you guys, so that sample assignment or that practice assignment is going to be very similar to your real assignment. If you have questions about that, you need to let me know. All right, take care, you guys.